Hello students, welcome to this lecture on conic sections. In this lecture, we will discuss NCERT miscellaneous examples 17 to 19 and exercise question number 1 to 8. This is disclaimer. So first we will cover NCERT miscellaneous exercise example 17 to 19. Then we will cover NCERT miscellaneous exercise question number 1 to 8. So make sure you are with your notebooks and pens ready. So let's get started. Look at NCERT miscellaneous example 17. In this example, we have the focus of a parabolic mirror as shown in figure 10.31 is at a distance of 5 cm from its vertex. If the mirror is 45 cm deep, then find the distance AB. So we will solve this example now. Since the distance from the focus to the vertex is given to us 5 cm. So we have A is equal to 5 if the origin is taken at the vertex and the axis of the mirror lies along the positive x-axis, then the equation of the parabolic section is y square is equal to 4 times ax. Here A is equal to 5 and x is equal to 45. So put the values of A is equal to 5 and x is equal to 45 in y square is equal to 4 times ax. Then we will obtain y square is equal to 4 times 5 into 45. It implies y square is equal to 900. Therefore, y is equal to plus minus 30. Hence, AB is equal to 2 times y. This is equal to 2 times 30 is equal to 60 centimeter. So the distance AB is 60 centimeter. I hope you are getting my point. So now let's move to the next example. In this example, we have a beam is supported at its ends by supports which are 12 meters apart. Since the load is concentrated at its center, there is a deflection of 3 centimeter at the center and the deflected beam is in the shape of a parabola. So how far from the center is the deflection? 1 centimeter. So students, first of all, think about this. How would you approach this example? So in this example, we have asked how far from the center is the deflection? 1 centimeter. So let the vertex be at the lowest point and the axis vertical. Let the coordinate axis be chosen as shown in figure 10.32. Okay, so the coordinate axis be chosen like this, that is shown in this figure. The equation of the parabola takes the form x square is equal to 4 times ay. Why? Because the parabola is opening upwards since it passes through the point 6, 3 by 100. So we have 6 square is equal to 4 times a into 3 by 100. That is a is equal to 36 into 100 upon 12. Okay, and 3 into 12 is 36. So here you can cancel by 3 into 12, that is 36. Okay, so you will get 3 into 100 equal to 300 meter. So a is equal to 300. Let AB be the deflection of the beam, which is 1 by 100 meter. Coordinate of point B are x, 2 by 100. Therefore, x square is equal to 4 times 300 into 2 by 100. This is equal to 24. So x square is equal to 24. That is x is equal to square root of 24 and x is equal to 2 times root 6 meters. Okay, so the deflection 1 centimeter is 2√6 meters far from the center. I hope it is clear to all of you. So now let's move to the next example. In this example, we have a rod AB of length 15 centimeter raised in between two coordinate axes, that is x-axis and y-axis, in such a way that the end point of A lies on x-axis and end point B lies on y-axis. A point Px, y is taken on the rod in such a way that AP is 6 centimeter. Okay, so that the locus of P is an ellipse. So students, first of all, think about this. How would you approach this example? Let's solve this example. So in this example, we have to show that the locus of point P is an ellipse. So first of all, let AB be the rod making an angle theta with OX as shown in figure 10.33. Okay, and PX, Y be the point on it such that AP is 6 centimeter. Since AB is 15 centimeter and AP is 6 centimeter, so we have PB. PB is equal to 9 centimeter. How we get? By PB is basically AB minus AP. So PB is equal to 9 centimeter. From P point, we will draw PQ and P are perpendiculars on y-axis and x-axis respectively. Now from triangle PBQ, cos theta is equal to x upon 9. Why? Because we know cos theta is equal to base upon hypotenuse. Okay. So in triangle PBQ, base is x and hypotenuse is 9 centimeter. So cos theta is equal to x upon 9. From triangle PRA, sin theta is equal to y upon 6. Why? Because we know sin theta is equal to perpendiculars divided by hypotenuse. Okay, so here perpendicular is y and hypotenuse is 6 centimeter. So sin theta is equal to y upon 6. So from triangle PVQ, we obtain cos theta is equal to x upon 9. And from triangle PRA, we obtain sin theta is equal to y upon 6. We know that cos square theta plus sin square theta is equal to 1. So x upon 9 whole square plus y upon 6 whole square is equal to 1. This equation can be written as x square upon 81 plus y square upon 36 is equal to 1. Since this equation represents ellipse. Okay, so this equation is look like x square upon a square plus y square upon b square is equal to 1. So this equation is representing an equation of ellipse. So therefore, the locus of P is an ellipse. Thus the locus of P is an ellipse. Clear? I hope you are getting my point. Okay. So now let's move to the next slide. Now we will discuss NCERT miscellaneous exercise. So look at question number 1. So first read the question very carefully. Okay. So in this question we have, if a parabolic reflector is 20 centimeter in diameter and 5 centimeter depth, then find the focus. So how would you approach this question? First thing about this. Okay. So we have to find the focus of the parabolic reflector. So let's solve this question step by step. The origin of the coordinate plane is taken at the vertex of the parabolic reflector in such a way that the axis of the reflector is along the positive x-axis. Okay, this is how we have taken the vertex at origin. So this is the diagrammatical representation of the parabolic reflector. The equation of the parabola is of the form y square is equal to 4 times x. Why? Because the parabolic reflector is opening to the right side. Okay, this is why the equation of the parabola is of the form y square is equal to 4 times x. Since the parabola passes through the point 5, 10. Okay, so this parabola passing through the point A 5, 10. So 5, 10, this point satisfy the equation of the parabola. So it satisfies the equation of the parabola y square is equal to 4 times x. So it implies 10 square is equal to 4 times a into 5. It implies 100 equal to 20 times a. It implies a is equal to 100 upon 20 is equal to 5. Therefore, the focus of the parabola is a, 0, and we found that a is equal to 5. So the focus of the parabola is 5, 0. So I hope you are getting my point. So now let's move to the next question. In this question, we have an arch is in the form of a parabola with its axis vertical. The arch is 10 meter high and 5 meter wide at the base. So how wide is it 2 meter from the vertex of the parabola? So students, first of all, think about this. How would you approach this question? So what we have to do here, we have asked how wide is it 2 meter from the vertex of the parabola. So let's solve this question step by step. The origin of the coordinate plane is taken at the vertex of the arch in such a way that its vertical axis is along the positive y-axis. Okay, so this is how we have taken the origin of the coordinate plane. Okay, the equation of the parabola is of the form here x square is equal to 4 times ay. Why? Because it is opening upwards. So this is the diagrammatical representation of the parabola. Okay. Since the parabola passes through the point 5 by 2, 10, so here you can see this is the parabola. Okay, and the parabola passes through the point 5 by 2, 10. So what can we say? So since the parabola passes through a point 5 by 2, 10, so it satisfies the equation of the parabola x square is equal to 4 times ay. So 5 by 2 whole square, this is equal to 4 times a into 10. It implies a is equal to 25 upon 4 into 4 into 10. This is equal to 5 upon 32. So we found that a is equal to 5 upon 32. So the equation of the arch of parabola becomes x square is equal to 5 by 8 times y. When y is equal to 2 meter, then it implies x square is equal to 5 upon 4, and it implies x is equal to square root of 5 by 4 meter. Therefore, AB, this is equal to 2 times square root of 5 by 4 meter, and here square root of 5 by 4 is approximately equal to 1.118 meter. Okay, so AB is equal to 2 times 1.118 meter, and this is equal to 2.23 meter approximately. So the arch is 2 meters from the vertex of the parabola. Its width is approximately 2.23 meter. I hope you are getting my point and it is clear to all of you. So now let's move to the next question. So first of all, read the question very carefully. So in this question, we have the cable of a uniformly loaded suspension bridge hangs in the form of parabola. The roadway, which is horizontal and 100 meter long, is supported by vertical wires attached to the cable. The longest wire being 30 meter and the shortest being 6 meter. Find the length of a supporting wire attached to the roadway 18 meter from the middle. So first of all, think about this. How would you approach this question? So let's solve this question step by step. So the vertex is at the lowest point of the cable. So the origin of the coordinate plane is taken as the vertex of the parabola, while its vertical axis is taken along the positive y-axis. And this can be diagrammatically represented as follows. Okay, so this is the diagrammatical representation of the parabola. Here AB and OC are the longest and shortest wires respectively. Okay, so AB is here longest wire and OC is shortest wire. So these two wires attached to the cable. And DF is the supporting wire attached to the roadway 18 meter from the middle. Here AB is 30 meter, OC is 6 meter and BC is 100 upon 2 is equal to 50 meter. So we found here AB is 30 meter, OC is 6 meter, okay, and BC is 100 upon 2 is equal to 50 meter. So the equation of the parabola is of the form x square is equal to 4 times ay, as it is opening upwards. What is the coordinate of point A? The coordinates of point A are 50, 30 minus 6. This is equal to 50, 24. Since the point A, 50, 24 is a point on the parabola. Okay, so what can we say here? So it satisfies the equation of the given parabola x square is equal to 4 times ay. So we will obtain 50 square is equal to 4 times a into 24. And it implies a is equal to 50 into 50 upon 4 into 24. This is equal to 625 upon 24. So therefore the equation of the parabola is x square is equal to 4 times 625 upon 24 into y. Okay, and simplify it, then you will get the equation of the parabola is 6x square is equal to 625y. The x coordinate of point D is 18. Hence, at x is equal to 18, 6 into 18 square is equal to 625y. And it implies y is equal to 6 into 18 upon 625. It implies y is equal to 3.11 approximately. Therefore, DE is 3.11 meter and DF is basically DE plus EF, and D is here 3.11 and EF is 6 meter. Okay, so DF is equal to 3.11 meter plus 6 meter is equal to 9.11 meter. So df is equal to 9.11 meter. Thus, the length of the supporting wire attached to the roadway 18 meter from the middle is approximately 9.11 meter. Okay, I hope it is clear to all of you. So now let's move to the next question. In this question, we have an arch is in the form of a semi-ellipse. It is 8 meter wide and 2 meter high at the center. Find the height of the arch at a point 1.5 meter from one end. So students, first of all, think about this. How would you approach this question? So what we have to find here? We have to find the height of the arch at a point 1.5 meter from one end. So given that the height and width of the arch from the center is 2 meter and 8 meter, so it is given that the length of the major axis is 8 meter and the length of the semi-minor axis is 2 meter. So the origin of the coordinate plane is taken as the center of the ellipse, while the major axis is taken along the x-axis. Hence, the semi-ellipse can be diagrammatically represented as follows. Okay, so this is the diagrammatical representation of the semi-ellipse. The equation of the semi-ellipse will be of the form x square upon a square plus y square upon b square is equal to 1, where a is greater than or equal to 0, where a is the semi-major axis and b is semi-minor axis. So semi-major axis is a, okay, and b is semi-minor axis, and we know length of major axis is 2 times a. Okay, so 2 times a is equal to 8, and it implies a is equal to 4. And b is equal to 2. Therefore, the equation of the semi-ellipse is x square upon 16 plus y square upon 4 is equal to 1. Okay, and here y is greater than or equal to 0, naming this equation equation number 1. Now let A be a point on the major axis such that AB is 1.5 meter. And now draw AC perpendiculars 1 AB, and OA is 4 minus 1.5 meter is equal to 2.5 meter. The x coordinate of point C is 2.5. The x coordinate of point C is 2.5. And on substituting the value of x is equal to 2.5 in equation x square upon 16 plus y square upon 4 is equal to 1. So we get 2.5 whole square upon 16 plus y square upon 4 is equal to 1. And it implies 6.25 upon 16 plus y square upon 4 is equal to 1. So it implies y square is equal to 4 times 1 minus 6.25 upon 16. And it implies y square is equal to 4 times 9.75 upon 16. It implies y square is equal to 2.4375. So y is equal to approximately 1.56. Therefore, AC is 1.56 meter. Thus, the height of the arch at a point 1.5 meter from one end is approximately 1.56 meter. I hope it is clear to all of you. Now, let's move to the next question. In this question, we have a rod of length 12 centimeter moves with its ends always touching the coordinate axis. Determine the equation of the locus of a point P on the rod, which is 3 centimeter from the end in contact with the x-axis. So first of all, think about this. How would you approach this question? So let's solve this question step by step. First, let AB be the rod making an angle theta with OX. OX means positive x-axis, and PX, y be the point on it such that AP distance is 3 cm. And then PB is equal to basically AB minus AP, and AB is 12 centimeter and AP is 3 centimeter. So PB is equal to 12 minus 3 centimeter, that is equal to 9 centimeter. Okay. And from P point, we draw PQ perpendiculars to OY and PR perpendiculars to OX. So you can visualize in this figure. Okay. So we have drawn here the line PQ perpendiculars to OY and PR perpendiculars to OX. In triangle PBQ, cos theta is equal to base upon hypotenuse. So base is here PQ, okay, and hypotenuse is here PB. So PQ is x and PB is 9. So cos theta is equal to x upon 9. And in triangle PRA, sin theta is equal to perpendicular divided by hypotenuse. Okay, so here perpendicular is PR and hypotenuse is AP or PA. Okay, so sin theta is equal to y upon 3, since here PA is equal to 3. So we found that sin theta is equal to y upon 3 and cos theta is equal to x upon 9. Since we know sin square theta plus cos square theta is equal to 1, so we will obtain by putting sin theta is equal to y by 3 and cos theta is equal to x upon 9 in sin square theta plus cos square theta is equal to 1, y upon 3 whole square plus x upon 9 whole square is equal to 1. And this can be written as x square upon 81 plus y square upon 9 is equal to 1. Thus, the equation of the locus of point P on the rod is x square upon 81 plus y square upon 9 is equal to 1. So, I hope it is clear to all of you. So, now let's move to the next question. So, in this question, we have to find the area of the triangle formed by the lines joining the vertex of the parabola x square is equal to 12 times y to the ends of its latest rectum. So students, first of all, think about this. How would you approach this question? So let's solve this question step by step. So the given parabola is here, x square is equal to 12 times y. Now on comparing equation x square is equal to 12y with standard equation of parabola x square is equal to 4 times ay. We obtain 4 times a is equal to 12 and it implies a is equal to 3. Therefore, the coordinates of foci are s 0, a is equal to s 0, 3. Okay, so the coordinates of the foci are 0, 3. Now let AB be the latest rectum of the given parabola. The given parabola can be roughly drawn as follows. Okay, so this is how we can draw the given parabola. Okay, so this is the diagrammatical representation of the given parabola x square is equal to 12y. So this is the diagram of x square is equal to 12y, and at y is equal to 3, x square is equal to 12 times 3. It implies x square is equal to 36. Okay, and it implies x is equal to plus minus 6. Therefore, the coordinates of point A are minus 6 comma 3, while the coordinates of point B are 6 comma 3. Therefore, the vertices of triangle OAB are 0 comma 0, minus 6 comma 3 and 6 comma 3. Okay, and we know that area of triangle OAB is equal to 1 by 2 modulus of x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. Okay, here x1 is 0, y1 is 0, x2 is minus 6, y2 is 3, and x3 is 6 and y3 is 3. So now putting these values into the formula, and then we will get the area of triangle OAB. So area of triangle OAB, this is equal to 1 by 2 modulus of 0 times 3 minus 3 plus minus 6 times 3 minus 0 plus 6 times 0 minus 3 in square unit. This is equal to 1 by 2 modulus of minus 6 into 3 plus 6 into minus 3 square unit. This is equal to 1 by 2 modulus of minus 18 square unit. This is equal to 1 by 2 into 36 square unit. This is equal to 18 square unit. So area of triangle OAB is 18 square unit. The required area of triangle is 18 square unit. So I hope it is clear to all of you and you are getting my point. Okay. So now let's move to the next question. So look at question number 7. So in this question, we have a man running a race course notes that the sum of distances from the two flag posts from him is always 10 meter and the distance between the flag post is 8 meter. So find the equation of the post traced by the man. Okay. So students, first of all, think about this. How would you approach this question? So we have to find in this question the equation of the post traced by the man. Okay, so let's solve this question step by step. So first let A and B be the positions of the two flag posts and Px, Y be the position of the man. Okay, so it implies PA plus PB is equal to 10. And we know that if a point moves in a plane in such a way that the sum of its distances from two fixed points is constant, then the path is an ellipse. Okay, so this constant value is equal to the length of the major axis of the ellipse. Therefore, the path described by the man is an ellipse where the length of the major axis is 10 meter, while points A and B are the foci. Okay, so this is the diagrammatical representation of the path described by the man, which is an ellipse. So the equation of the ellipse will be of the form x square upon a square plus y square upon b square is equal to 1, where a is the semi-major axis and b is semi-minor axis. So 2a, this is equal to 10, it implies a is equal to 5. and distance between the foci is basically 2c, and we have given here distance between two foci is 8. So 2c is equal to 8. So it implies c is equal to 4. So we found that a is equal to 5 and c is equal to 4. And we know the relation c is equal to square root of a square minus b square. So we obtain 4 is equal to square root of 25 minus b square. It implies 16 is equal to 25 minus b square. And from here you will get b square is 25 minus 16 is equal to 9. So it implies b is equal to 3. Thus the equation of the path traced by the man is x square upon a square plus y square upon b square is equal to 1. So which is equal to x square upon 25 plus y square upon 9 is equal to 1. Okay, so this is the equation of the path traced by the man. So I hope it is clear to all of you. So now let's move to the next question. In this question, we have an equilateral triangle is inscribed in the parabola y square is equal to 4 times x, where one vertex is at the vertex of the parabola. Then find the length of the side of the triangle. Okay, so you have an equilateral triangle, and this equilateral triangle is inscribed in the parabola y square is equal to 4 times x, and where one vertex is at the vertex of the parabola. Okay, so we have to find the length of the side of the triangle. So let's solve this question first. Okay, so how would you approach this question? First, think about this. So what we have to find here? We have to find the length of the side of the triangle. So first let OAB be the equilateral triangle inscribed in parabola y square is equal to 4 times x. So first let here AB intersect the x-axis at the point C. So this is the diagrammatical representation of the equilateral triangle inscribed in parabola y square is equal to 4 times x. Okay, so you can visualize here, this is our equilateral triangle OAB. Okay, and this is the parabola y square is equal to 4 times x. So first let OC is equal to k. Okay, so OC, this distance is k. So we have seen OC distance is k. Okay, so we basically assume that OC is equal to k unit, and then OC is equal to k. Then from the equation of the given parabola, we have y square is equal to 4 times ak. Okay, so it implies y is equal to plus minus 2 times root ak. Therefore, the respective coordinates of points A and B are k comma 2 times root ak and k comma minus 2 times root ak. So these are the respective coordinates of points A and B. So AB is equal to CA plus CB. Okay, so CA is equal to 2 times root AK and CB is equal to 2 times root AK. So AB is equal to 2 times root AK plus 2 times root AK is equal to 4 times root AK. So AB is equal to 4 times square root of AK. Since OAB is an equilateral triangle, so OA square is equal to AB square. So OA square is equal to AB square. So by using the distance formula between O and A, and we have AB is 4 times square root of AK. So therefore k square plus 2 times root AK whole square, this is equal to 4 times root AK whole square. It implies k square plus 4 times ak is equal to 16 ak. It implies k square is equal to 12 times ak. It implies k is equal to 12 times a. So AB is equal to 4 times root AK, and here K is equal to 12 times A. So AB is equal to 4 times square root of A into 12A, and this is equal to 4 times root 12A square. This is equal to 8 times root 3A. The side of the equilateral triangle inscribed in parabola y square is equal to 4 times AX is 8 times root 3 times A. Okay, so 8 times root 3 into A is the length of the side of the equilateral triangle inscribed in parabola. So I hope it is clear to all of you. That's all for today's lecture. Thank you very much to all of you.